Hello students, today I discuss some problems related with matrix and determinants. So there is the first problem, problem 1. Here it is that a matrix M given 3 order matrix minus 1, 3, 5, 1, minus 3, minus 5, minus 1, 3, 5, each. First option is given nilpotent matrix, nilpotent matrix. B option is given idempotent matrix. C is given involutory matrix. Involutory matrix. Third option given. Fourth option given periodic. So what type of this matrix is? We have to find out this answer. Let's solve this question. So to check out that what type of this matrix, we will find out first what is M is given, what is M square. What is M square? M square can be found out in this way. M multiply M. Multiply M. So what we have, write down the matrix twice, multiplication, minus 1, 3, 5, 1, minus 3, minus 5, minus 1, 3, 5. Again we will write down matrix multiplication, minus 1, 3, 5, 1, minus 3, minus 5, minus 1, 3, 5. You have to use a rule of the matrix multiplication. We know the rule of the matrix multiplication, how a matrix multiplication is performed. Here we have to do that. To take the first matrix, the row, and the second matrix, the column. This is we have to do the matrix, first matrix first column, first matrix second column, first matrix third column will give us the first row of the multiplication. I mean to say this. We'll find out the first row of the matrix multiplication by the first row first column, first row second column, first row third column. This will be minus 1 plus 1 plus 3 1 3 plus 5 minus 1 minus 5. This is the our first first row first element. Now first row second column, this will give us second element in the first row, minus 1 and 3, minus 3, then minus 3 and 3 minus 9, and then 5 and 3 15 plus 15. Now we'll find out third element in the first row. So first row third column, this will be minus 5, this will be minus 15, and this will be plus 25. You need to check out it is very sensitive to matrix multiplication, so there may be any mistake. So you need to repeat the to find out that what you have done. So I am looking checking this minus 1 plus 1, 3 and 1 plus 3 plus 3, and 5 and minus 1 minus 5, minus 1 and 3 minus 3 minus 3 3 minus 9 3 and 5 plus 15. Okay, now 5 minus 5 minus 15 and plus 25. So this is okay, the first row. Now we find out second row. So we will take the second row of the first matrix. This is the second row of the first matrix, and first column of the second matrix. So here second row first column, second row second column, second row third column will give us second row of the matrix multiplication. So what we will do here, 1 and minus 1 minus 1 minus 3 and 1 minus 3 minus 5 and minus 1 will give us plus 5. And now second row second column, so 1 and 3 will give us 3, minus 3 and minus 3 plus 9, and minus 5 and 3 versus us minus 15. Now 1 and 5, 5 minus 3 and minus 5 plus 15, and minus 5 and 5 minus 25. So again we check this is okay or not. 1 minus 1 minus 1 minus 3 minus 3 minus 1 minus 1 minus 1 minus 3 1 minus 3 minus 5 minus 1 plus 1 3 3 minus 3 minus 3 plus 9 minus 5 3 minus 15, 1 5 5 minus 3 minus 5 plus 15, and minus 5 5 minus 25. Now we will get third row by getting third row first column, third row second column, third row third column. So here minus 1 plus 1, 3 1 3 plus 3, and 5 minus 1 minus 5. Now third row second column, minus 1 and 3 minus 3, this will be minus 9 minus 3 plus 3, and this will be 5 5 3 15 plus 15. So here third row third column will be minus 1 and 5 minus 5, Here minus 5 and 3 minus 15 and 5 5 25, so plus 25. Need to check again. Minus 1 minus 1 1 3 and minus 5. Minus 3 minus 9 5 3 are 15 and minus 5 minus 15 and plus 25. Now we will find out. This will be again 3 order of matrix. So this will be 4 minus 5 minus 1. Here it will be minus 12 plus 15 3. Here it will be minus 20 plus 25 5. So now it will be again 1. It will be now 12 minus will be minus 3. And here it will be again minus 5. Here it will be minus 1. Here it will be plus 3. And here it will be plus 5. So if you look what is the matrix given, the matrix is given is the same as we have found out the M square, the after matrix multiplication. This is the same as the matrix given. The square of the matrix is same with the matrix given. So this must be idempotent matrix. If any matrix satisfied is its square is equal to with the same with the matrix, then it is a idempotent matrix. Therefore, B option is correct. B option is correct. So it is an idempotent matrix. Now I'll go in second problem. So the second problem is given if M is equal to minus 5, 3, 1, minus 8, 5, 2, 0, 0, minus 1, then M is first option nil quadrant, second option orthogonal, third option, periodic. Fourth option, involuntary. Again we solve this. Here we will take, here m is given, we need to find out m square to check that what type of the matrix is. So we need to find out m square again. So m square will be minus 5 minus 8 0 3 5 0 1 2 minus 1, and this will be again minus 5 minus 8 0 3 5 0 1 2 minus 1. Then we do the matrix multiplication. This will be 25 minus 24 plus 0. Here it will be minus plus 40 minus 40 and then 0. And here it will be 0 0 0, just 0. Again the second row, minus 15 plus 15 and then 0. Now it will be minus 24 plus 25 plus 0, and here it will be again 0 0 0. Again minus 5 minus 5 plus 6 and minus 1. It will be minus 8 plus 16 plus 10, sorry, 10 minus 2. It will be 0 0 0 and minus plus 1. Then we will have here, it will be 1 0 0 0 1 0 0 0 1. So it is a 3 order of identity matrix. It is 3 order identity matrix. So if any matrix square is equal to identity matrix, then the matrix must be involuntary. So the matrix, the given matrix is in row A so which option is correct? The inverter is given D option. So D option is correct. E is correct. Now I'll go another problem. Third problem. If A is equal to M is a matrix, 2 matrix, so 3 minus 2, 4 minus 2 satisfies the matrix equation, satisfies the matrix equation matrix equation M square minus lambda m plus 2 into identity matrix of order 2 is equal to 0 matrix of order 2. So if this is true, then the value of lambda, then find the value of lambda. So here we can solve this in two ways, two procedure we can follow. If you know uh, uh, Cauchy-Hamilton equation, that every characteristic, every uh, uh, matrix satisfied is characteristic equation. So the Cauchy-Hamilton theorem, every uh, matrix must satisfy is the characteristic equation. Cayley-Hamilton theorem, sorry. Cayley-Hamilton theorem, that every Cayley-Hamilton theorem, we can use Cayley-Hamilton theorem to solve this. It will be here. So by Cayley-Hamilton theorem, we need to find out the characteristic equation of it. So its characteristic equation can be found out if we found out the eigenvalue of it. So its characteristic equation of this matrix is characteristic equation of the matrix A is minus color equal to 0. So this must be equal to 0. So what we can find out, we will have A and ID. This is identities of 2 to order. So we will find out this. This will be 3 minus lambda minus 2. This will be 4. This will be minus 2 minus lambda is equal to 0. You can very easily find out this from this will find out. Now the characteristic equation will be minus 2 plus lambda into 3 minus lambda plus 8 is equal to 0. So from it we will find out the characteristic equation. And this will be minus 6 minus 3 lambda plus 2 lambda plus lambda square plus 8 equal to 0. So what is the characteristic equation? The characteristic equation is lambda square minus lambda plus 2. So if this is the characteristic equation, so it must be satisfied by Cayley-Hamilton theorem by the matrix A. So we have this must be satisfied by the square matrix. This we can write down m square minus m plus 2 into identity matrix of 2 to order is equal to 0. Matrix of 2 to order. So what is here? If we compare here, this equation is also satisfied by this matrix, and here also this by Cayley-Hamilton theorem. This is the equation satisfied by the matrix. So if we compare both of them, we have lambda is equal to 1. We have lambda is equal to 1. So this is the solution of this problem. Now we need to go in fourth problem. This is a good problem. If A and B idempotent matrices of same order, same order, then then A plus B is idempotent idempotent a matrix if and only if and only if first option AB is equal to BA, A and B are commutative, A into B is equal to B into A. Second option AB is equal to 0, AB is equal to 0 matrix of same order. C BA is equal to 0, matrix of same order, or D AB plus BA is equal to 0 matrix of same order. So let's find out the solution. Given that A and B are idempotent matrix, so what we'll have, A square is equal to A and B square is equal to B. Now also given that A plus B square is an idempotent matrix. Also A plus B whole square is an idempotent matrix. If we take this is an idempotent matrix, that what happens, A plus B whole square is equal to A plus B. Then it implies that A plus B into A plus B is equal to A plus B. Now we'll have we have matrix multiplication. We will find out A square plus B into A plus A into B plus B square is equal to A plus B. So what we will have, we know that A square is equal to A and B square is equal to B. So we will have A plus, here we arrange this, A, B plus B plus B is equal to A plus B. So same matrix subtraction we know it will be a zero matrix. If we use same matrix multiplication, A minus A is zero matrix. We know that this is zero matrix of same order. So we'll use this here. Then this and this will be omitted, and this will be omitted. So we have AB plus BA equal to 0. Also, if we take this, then also oppositely, you can prove that you will get A plus B idempotent matrix. Both sides implies that. If we take this, then this implies that the A plus B, AB in plus BA is equal to 0. And if we take this, then also you will get A plus B and idempotent matrix. So D option is correct.